Okay, now to motivate or begin thinking about the idea of potential energy, we can consider what happens if I crouch down and jump up. Okay, now if I crouch down and jump up, I probably won't go very far off the floor anymore. And I'm not going to go up 60 centimeters. My mass is probably closer to 80 kilograms than 70, but I try to keep it closer to 70. So let's just assume this is me, 80 kilograms, trying to jump 60 centimeters up. Now maybe I don't jump 60 centimeters up, maybe I just crouch down 60 centimeters and raise myself up. If I do that, then the question is, does gravity do work on my mass? Okay, well, certainly whether I'm airborne, whether I'm in an actual vertical leap, if you can call it that, or whether I'm just standing here, gravity is exerting a force on me, which, if there's nothing to support me, will accelerate me downward at 9.8 meters per second squared. So, gravity is exerting a force that we can calculate easily by multiplying my 80 kilogram mass by the acceleration of gravity, which is 9.8 meters per second squared. Well, let's just round that off to 10 meters per second squared. Let's pretend gravity is a little stronger today. That doesn't happen, but let's pretend it did. Okay, so the force of gravity exerted on my mass is what? The mass times the acceleration of gravity, 800 newtons. Okay, so gravity does work by exerting a force of 800 newtons on me, 800 newtons exerted downward as I move 60 centimeters upward. Now we've got to take a positive direction in order to calculate the work done by gravity. So we're going to take upward to be the positive direction. It wouldn't matter, you could use downward for the positive direction. You're going to get the same result for the work, as I'll explain in a second, but let's stick with upward for the moment. So the force of gravity is then negative 800 newtons, because it's 800 newtons downward, multiplied by the 0.6 meter displacement, which is upward. So we have a negative force multiplied by a positive displacement, giving us a negative result for the work. And the arithmetic is easy, and Newton meters is joules. So we're going to get negative 480 joules of work done by gravity. Okay? Now, just to digress, if I'd chosen downward to be positive, then the force of gravity would have been positive, but our upward displacement would have been negative, and we would have still gotten negative work. So it doesn't really matter what direction we choose for the positive direction. The work in this situation is going to come out negative. What's the reason? Because the direction of the force is in opposite the direction of the displacement. So we have a negative 480 joules. We have negative 480 joules of work done by gravity. Now, let's say I did do a vertical leap and managed to rise 60 centimeters, which is about 2 feet, actually. And that's certainly higher than I can jump. That's not a terribly bad jump for a healthy young person. So if I jump up, fall back down, what work does gravity do as I come back down? Well, it does work by exerting a downward force, but now there's a downward 0.6 centimeter displacement. And I really should have parentheses around that, giving me positive 480 joules of work, or doing, the result is positive 480 joules of work. So gravity will do 480 joules of work as I come back down that 60 centimeters. Well, if by virtue of being 60 centimeters up the floor and by doing nothing else but being there and not being supported at that height, I spontaneously fall back down due to the acceleration of gravity, due to the force exerted on my mass by gravity, then in a sense I have the potential to gain 480 joules of kinetic energy, and that's exactly what happens. So that at the 60 centimeter height, we could say I had 480 joules of potential energy relative to the floor. So there's an example of having potential energy, having the potential to develop some sort of energy or do some sort of work. In this case, we'd be developing kinetic energy at the expense of potential energy by virtue of where I am, my position. Okay, so work calculations for work done by gravity going up, coming down, and a mention of the idea of potential energy.